The table saw, an indispensable piece of the maker shop. I love mine. It's a bit old, but I have it dialed in. It works beautifully. One thing a lot of makers do with their table saw is create jigs and modifications that allow you to do more things with it. One such modification is creating a zero clearance insert. Now the insert is the piece that the blade comes up through, and it's removable so you can change the blade, do adjustments, clean it out, all that kind of stuff. The ones that come stock have this wide gap for the blade, and that's important because it allows you to tilt the blade without coming into contact with anything here. This is useful for almost any application you want to use your table saw for, except of course cutting really narrow strips. This 1/4 inch wide strip will fall down through that gap, likely come in contact with the blade, break, and possibly even be thrown back at you, which could be a significant hazard. The way around that is to make a zero clearance insert, and most woodworkers, makers, use wood. Why not? It's a great material, you're already set up to do it, you cut that to shape, and then you put it in and you run the blade up through to get your zero clearance. This way, nothing can fall down in there. It couldn't be simpler, but I decided to make it hard. I wanted to make one out of metal. I thought about a lot of different variables and came to the conclusion that aluminum would be best for it. Here's the sheet that I used. It's 1/8 inch thick. Incidentally, the same thickness as my original plate, so a lot of the dimensions and so on and so forth would be the same. I then just cut that to size using my table saw. Next, I need to make it to this shape. And what I did is double side tape it to this existing plate. I put a 1/4 inch piece of wood in between it as a spacer, and then using a cutoff router bit. If you're familiar with these, they have a bearing on the top that can run along a guide or a straight edge, and anything below it will be cut flush to the same dimensions as your template. It worked fine until I got to this gap. Now my plan was to take this off, reattach it upside down with that little nib sticking out, and then buzz off the remaining piece. The problem is I didn't put new tape on, and the mount slipped and it gouged it out ever so slightly. I gave it a second try. What I did then was I cut this template first in the same manner as before, and used this sandwiched in between another plate that I cut and the existing plate, and cut that out. Now I have 2 of those. To cut the slot in it, what I did was I took this piece and I routed this into it so the blade wouldn't come in contact with it, and I put it down in the table saw. I then sandwiched my cutout aluminum template that had yet to have any holes or slots in it down in that. On top of that, I clamped down a piece of 1/2 inch plywood. Then it's just a matter of simply turning the saw on and cranking up the blade to run it through, and then back down. And that creates this slot. Next step, layout fluid. Machinists use it all the time. It's a precise way to mark points for drills, lines for cut, you name it. Layout fluid works beautifully. Sprayed that outside using a respirator, and then came back in and went through the process of marking out all my holes. Since this is an identical piece to the steel insert, I simply use this as a template, utilizing the 90-degree angle of my crosscut sled to butt them up against one another and lay out all those holes. After I laid everything out, then I went in and used an automatic center punch to mark where my drill points would be. It's a great way because you can line it up and then bust that hole out. Check them out if you haven't used one. Okay, now that I have those marked, put it in the drill press and use a center drill first to make pilot holes for everywhere I needed to drill, and then I went back with the appropriate size bits for all of those holes. 4 of the holes that I'm drilling are for these leveling screws. These are just set screws that are threaded into the plate and can be adjusted to make sure that this is flush with the deck of your table saw. They're M5, and I wanted to use the exact one, so I picked up some M5 by 5mm set screws, and I have the thread tapping set to do that, and I drill the holes. Number 19 drill bit works well for the M5s, and went through and set all that up. Now, I need to go in and countersink these holes or create a circular chamfer around them. One for the locking screw in the front, and then also I wanted to chamfer each of the 4 set screws. I'll do that after I thread them. The 2 holes in the front have a space between them. To make this, I used a Dremel and ground out the majority of the material. I followed that by using a file and cleaned it up with some sandpaper. I need to now go in and create the clip. This is the part that slips on the back. There's a clip here. It's made out of high-strength spring steel. And then in the front, there's a hole that you can slide in and a lock screw goes here. And this ensures this thing doesn't fly out. Now, you don't have to do that on a wood one. Chances of it flying out are next to none. But because I was making it out of metal and I was trying to replicate this, I thought I'd go ahead and do it. I didn't realize that this would be one of the hardest parts of this entire build. I looked and looked for appropriate steel. It can't just be regular flat steel because when you bend that, it doesn't go back. It has to be hardened, flat spring steel. And what I ended up using was a feeler gauge. I found these at Marshall Supply, my favorite industrial hardware supply store. And this is a .025 thickness, which is the exact thickness of the spring here. Cutting it was difficult and drilling it was very hard. This is hardened steel and it's spring steel, so it comes back. It does not like to be changed at all. I worked and worked on it. I was able to cut it using a cutoff blade for my Dremel and a few attempts to get through, drill the holes, and get the right shape. All right, 2 clips made, finally. It's just about assembly. Going in, putting those pieces on, getting it together. Got that assembled, put my leveling screws in, and I put it into the table saw. I wanted an addition to this project, and that was to create a splitter. A splitter keeps the board from sliding over into the blade, which is one of the most dangerous parts of using a table saw. When that happens, you get kickback, and that's what throws wood back at you. And this blade is spinning incredibly fast. A piece of wood flying at you, or worse still, a piece of metal, can impale you. People die from this, and this is not something you want to have happen. Mine's old, and so it doesn't come with a riving knife, but a way around it are these kits. And the one I was going to use was this MJ splitter. Here's what happened. It didn't work. I used it per the instructions and went through the process. And when it came to the part of having the jig lined up that would allow you to create the holes needed for the inserts that go down in it, it slipped. And it slipped because my metal is hard. I didn't center punch those. I just jumped in and did it. One of the holes was a little off. All right, but these have adjustments in them so you can line that up. The reason that it really didn't work was the thickness. And the inserts that go in would wobble back and forth. It really needs a thicker piece underneath for those to line up well. I made 2, so that one can be set aside and used later. Once the splitter fail was out of my system, I went back to just cleaning these up and doing the finish on them. First, taking off the layout fluid is a simple matter. I use acetone. There's specific proprietary cleaners, which I believe include acetone. Wipes off really easily. And then I sanded it first using a palm sander to get any marks and any significant scratches out using 220 grit sandpaper. And then I went back and just gave it a nice buff using a couple different grades of Scotch pad and ended up with a really nice brushed looking finish on them. It turned out really well. Here they are. This one has 4 extra holes in it, but the finish is nice. They work well. The adjustment screws work exactly like I wanted, and these spring clips hold it in nice and safely. If you haven't worked with aluminum, I highly recommend jumping in. You don't have to be an expert machinist to use this material, and you can use a lot of your existing tools to make some pretty remarkable things.